Hey, thanks, Brett. And good morning, good afternoon, good evening, everybody. This is Jim White, EdgeX TSE Chair. Today we've got another of our Adopter Series presentations, this one from Canonical on running enterprise-grade Edge applications with EdgeX on Ubuntu Core. Just as a matter of policy, our LF trust policy, wanted to bring up for everybody's edification here. As I mentioned, today's presentation is going to be from Tony Espy and David Beamonte from Canonical. David, I hope I pronounced that okay. And they're going to show us a little bit about how running enterprise-grade applications with EdgeX can be done on Ubuntu Core. The slides are available, as you will see at the links below, essentially via our website, as well as through our wiki page. If you'd like, send us a note too. We'll make sure you get a copy. Today's presenters, again, Tony Espy. Tony is a technical architect of devices and IoT at Canonical. He's been there for 13 years, and he's also serving on our EdgeX Technical Steering Committee. In fact, I think Tony is next to myself and maybe a couple other folks, one of the longest serving members of EdgeX, has been there since its founding. So we really appreciate all the insight and the help that Tony's given. And besides that, he's just been a fantastic guy to work with. And he's also an EdgeX award winner, an award we give out annually in EdgeX to somebody who's either made innovation or contribution substantial to the project. So we welcome Tony. And along with Tony today is David. David is product manager of IoT and embedded products at Canonical, having joined there recently. But before that, he was with Telnet Redis Intelligentes. I hope I pronounced that as well. David, you'll have to correct me if I did not. And he was there for 21 years. So these guys have got some longevity in this business and know quite a bit about it. Hopefully today you will also pick up on some of their wisdom and learn a little bit about how EdgeX can run on Ubuntu Core. With that, gentlemen, I'm going to stop sharing and turn it over to you.
Okay, thank you very much, Jim. You have pronounced my name and my former company almost perfectly. Don't worry about that. Okay, please let me know if you can see my screen.
We can. Perfect.
Okay, thanks. Okay, so we're really happy to be here today to present Canonical's view of edge computing applications for devices deployed at scale, and of course, based on EdgeX. And we will also present our offering around it. Okay, my name is David Beamonte. As Jim has said, I am product manager for IoT and embedded systems at Canonical. And with me, it is Tony Espy, who is technical architect. Today, we are going to speak about EdgeX. Okay, that's for sure. But before that, we are also going to speak about security, about bulletproof updates, maintenance, and in summary, about reliable operating systems and edge applications. Okay, at the end of the session, if we have some time, that I think that we will try to just show a quick demo of our system based on EdgeX, one of our proof of concepts. And of course, we will try to have some time for Q&A, which I think will be really interesting for everybody. So let's get started with an introduction. For the last 20 years and even more, Linux has become the reference operating system for data center and cloud infrastructure. And this trend is, of course, going to continue. But okay, what happens with platforms with more constrained resources? As we know that as microprocessors, memories, and hardware in general have increased their performance, they have also been reducing their price. So now they are affordable for niches where traditionally microcontrollers were the undisputed leaders. So we are now reaching that point where business models, customers' needs, and hardware features are starting to meet, creating new markets in the IoT and field side. So although embedded Linux has been there for many, many years, a dramatic increase in the demand of Linux-based devices is expected for the next decade and so on. And as I mentioned, it is especially fostered by edge and IoT verticals where billions of devices will be present. So if you look at the scale, the challenge is really huge. A couple of examples that most of us can have in mind. Think of the billions of intelligent computers that we are increasingly seeing in our homes, or the billion of mission critical devices that will be necessary in industrial value chains. Both scale and criticality are increasing. So the Edge and IoT need a new breed of embedded systems. Many challenges such as connectivity, availability, and of course reliability are needed for this next generation of embedded systems. Most of them are not new, okay, but we must find new ways of facing them while improving security, simplifying operations, and reducing time to market. Basically allowing developers to focus on the application development and on the business case. So in this emerging, or not so emerging, but a reality nowadays, world of Edge and IoT, securing devices and data is a must. For instance, imagine how critical are applications like medical applications or banking applications. But not only those ones, everything is critical. And we see it every day on the media, for instance, with hacked systems with catastrophic effects that can cost millions to recover, or even worse, with the result of a damaged brand image, which can, of course, cost a lot of money, but also a lot of time to restore. So we must try to close all the doors and reduce vulnerabilities. Devices have to be ultra resilient because they are business critical. Operations can be very costly due to scale. We know that there is no on-site IT support in the field, so we need to improve operations experience to reduce OpEx. Devices can also last for decades in the field, so also long-term support and security and application updates are needed. So in summary, for Edge and IoT applications, what we need is a framework and underlying operating system and services, which allows us to focus on our application development so that we can accelerate time to market. A framework that helps us keeping operations and maintenance simple, saving OpEx, and of course, which is secure out of the box and keeps secure for the whole life of the devices on the field, as well as having long-term support. So Ubuntu Core is Canonical's proposal for that next generation of Edge and IoT Linux-based devices, whose main goal is to secure the new flavors of smart things. Ubuntu Core is a lightweight cross version of Ubuntu, removing all the unnecessary packages and so reducing footprint, which makes it very suitable for machines with constrained resources. It is an operating system designed to be inherently secure and hardened for security in different ways, such as cryptographic methods or application isolation, as we will see later. We are continuously observing when we look around that protecting our devices against vulnerabilities, as I mentioned earlier, is a key factor. So continuous effort on CVE fixing and robust deployment of security and application updates is crucial to keep our devices secure. So in summary, Ubuntu Core has been designed to be the best in class and reference solution across all the Edge and IoT verticals deployed at scale. IoT gateways, AML, consumer electronics, digital signage, robotics, automotive or industrial applications are just some examples where an ultra reliable and enterprise grade operating system like Ubuntu Core is definitely needed. And the question is, okay, how do we do that? Okay, what we have done with Ubuntu Core is to create a new operating system paradigm. Classic distributions architecture is based on applications deployed as packages which simply interrelate with each other. But with the appropriate permissions, they have full access to the full system. In Ubuntu Core, applications are based on snaps which are strictly confined and so are totally isolated from each other, and they can only interact with the system through some well-defined interfaces. This delivers better security and stronger resiliency. For those who don't know what snaps are containerized software packages which are bundled with their dependencies. And they are isolated from other packages and the system through the interfaces that I mentioned earlier. They are not containers like Dockers, okay, which emulate the full operating system, but they are applications that run on top of the operating system. Every snap is based on a base or core snap, which is a layer which makes the application feel as if it is running on top of a specific Ubuntu LTS version, core 16, 18, or 20. but the applications are actually running on top of the system with that intermediate abstraction layer acting as their runtime environment. So this and the fact that the snaps include the dependencies and libraries needed by the application make that portability issues mostly completely disappear. So in this new operating system paradigm, even the bootloader, the kernel, and the distribution base are snaps. Everything is snap, and only snaps which are strictly confined can be installed. Tony will explain in a deeper detail the benefits of EdgeX running as snaps and so on. Let's dive briefly into some of the features that I have mentioned so far. So the most important one is security, which is in the DNA of the operating system. Most of the developers who have worked with traditional embedded systems know how hard it is to struggle with these security features and the amount of effort and resources you need to invest if you have to develop them on your own. Ubuntu Core makes all these advanced security features available out of the box and with zero touch. Secure boot, full disk encryption are good examples of that, but also the nature of the operating system based on application confinement and transactional application updates are also good examples of this secure nature. The transactional updates are designed to be inherently secure. The deployed release doesn't become active until it has become completely updated. And there is an automatic rollback in the case that the update fails. In summary, all these features make it really secure. Ubuntu Core is also optimized for operations with the goal of being low-touch maintenance. And the most important feature is its ability to self-heal if eventually an update fails, performing an automatic rollback. Additionally, there is a recovery mode in which you can perform maintenance tasks. And the key point is that recovery mode allows the device to boot with a recovery system. But it keeps the network and accounts configuration so you can use it remotely. You don't have to send a technician to the field. And once our devices are on the field, its life will typically span for many years, and we want them to be as secure as the very day that they were deployed. So we believe that customers and developers need to feel confident with us, and that's why we engage with long-term relationship with them. And with this long-term engagement, we offer support and security and application updates for up to 10 years. So I have continuously mentioned security and application updates, and this is done via stores. The Snap Store is the open public store where anybody with an account can publish applications, and which is the default for the devices unless otherwise specified. A brand store is a private store for having a limited number of applications for a group of devices. This allows full control over that private store content. And as I described in a previous slide, the store provides those kind of mission critical bulletproof transactional upgrades. Okay. Additionally, it is worth mentioning that only Delta data is transferred during updates, saving bandwidth, which is very important for devices using protocols like narrowband IoT or CAT-M. Okay, with this, I finish my introduction, and then we can go to Tony's slides, which will just dive a little bit deeper in the technical details of our solution. Yours.
Great, thank you, David. Good morning, good afternoon, everybody. My name's Tony Espy. As Jim mentioned earlier, I'm a technical architect in our devices and IoT field engineering organization. And I've also been involved with the EdgeX Technical Steering Committee from the beginning. David's given you a pretty good overview of Ubuntu Core and why it's important to secure devices on the edge. What I'm going to talk about are some of the changes we've made to the EdgeX snaps that make it easy to build EdgeX Ubuntu Core images. So just super brief overview. I think David just hit on most of these points, but snaps are essentially a hybrid of a traditional Linux package and a container. They're digitally signed, the updates are transactional, And as David just said, they support binary delta downloads for updates. One point that's not always clear to people is snaps can run on any Linux distro with snapd installed. However, to get the benefits of full confinement, to have snaps be fully locked down requires some flavor of Ubuntu, whether that be core, desktop, or server. And then one last point I'll mention here is that unlike typical OCI containers, snaps can easily provide multiple services in a single snap. And this is done because we essentially can leverage systemd behind the scenes, which means there's no need for you to actually add another init system into your container. It just comes with the basic functionality of snaps. Next slide, please. So let's talk about EdgeX Foundry snaps. Canonical took over publishing of the EdgeX snaps in the Snap Store last fall. The snaps are all based on upstream releases. There are no changes made to the core functionality. However, we do maintain GitHub mirrors of all of the EdgeX Git repositories, which give us the ability to patch the snaps. The snap named EdgeX Foundry provides everything you need to run EdgeX. Beyond that, there are standalone snaps that exist for app service configurable and a growing number of device services. Next slide, please. And this is the current list of snaps that are available from the Snap Store. Includes the EdgeX client. You'll notice the UI is not here. That is something that we intend to work on as part of the Jakarta cycle. And then there are a couple here that are asterisked, EdgeX Device Grove and the RFID device service snaps. Those are still in progress at the moment. Next slide, please. So the EdgeX Foundry snap, as I mentioned earlier, snaps can provide multiple services, not a single service like is what's typically done with Docker. So the EdgeX Foundry snap provides the minimum set of services required to run EdgeX. Plain and simple, you can install it and you have EdgeX running on a machine. It includes all of the runtime dependencies. So this includes console, Redis, Kong, Vault. It includes the reference rules engine, which is Kuiper. And we actually also include app service configurable to front-end Kuiper within the snap. And finally, we include device virtual because, hey, if you're going to install EdgeX for the first time, the first thing you're going to do is play around with a virtual device service. So we decided to include that in the main snap. So it's already there and you don't have to run another command to get it. Some of the services in this snap are disabled by default. This has actually been a topic at the recent face-to-face, talking about how we add dynamic services and can you have services that are part of an EdgeX instance that are disabled by default. So for instance, support notifications and support scheduler, we disable them by default. They can be individually enabled either using a snap command line or via the snap REST API, but out of the box, they're not running. Security is also enabled by default. And when I talk about EdgeX security in the Hanoi release, there really are two components of that. There's the API gateway, which protects access to the EdgeX services from an external device. And there is the secret store, which provides storage for passwords or other secret credentials. And the final point I'll make is console is enabled by default and cannot be disabled. Now, for those of you that don't have a deep knowledge of EdgeX, console is used for two things within EdgeX. It's used as a service registry, so we know what services are running and how to talk to them. And it's also used as a store for configuration, so that services can save their configuration into console. And it's possible with Docker, or if you're running EdgeX natively, to run EdgeX in a mode where console isn't enabled. And we just made the decision that there's just so much more benefit running with console that it's always enabled. Next slide. A little bit about the Snap Store. The Snap Store has this concept of channels, which indicate risk, and tracks, which allow us to provide multiple versions. So the default channels are just stable, beta, candidate, and edge. We use edge to publish daily builds. So if you today, you can get the daily builds of the Ireland release of EdgeX Foundry from latest to edge. Beta and candidate are channels where we put versions of a snap that we're ready to release, but we may want some feedback and we may want some testing from the community. So today, the snaps in the latest beta channel are all based on Hanoi, and that actually should read latest stable and beta because there are snaps available in latest stable. But many of the features that I'm going to talk about in the next few slides are currently only available from the beta channel. So again, if you want to play around with anything that I talk about today, use the beta channel. We plan on releasing these to stable in about the same time as Ireland in the next week or so. And then the last point, I talked about channels, right? Channels are levels of risk. Tracks are actually about versions. So when Ireland releases, Ireland will be a 2.0 release of EdgeX. And so we are creating a new track called 2.0 so that you will be able to get the Ireland version of EdgeX from 2.0 stable. And we'll keep Hanoi in latest stable probably until Jakarta releases, which is our target LTS release. Next slide, please. So let me talk a little bit about application and device server snaps. So the EdgeX Foundry snap provides you the full framework, but if you actually want to do something with your EdgeX instance, you need to talk to devices and you need an application on the northbound side to export your data to the cloud or on-prem or potentially local rules engine. So by default, we install EdgeX and device services with the services disabled by default. So if you install the snap, nothing's running. The reason we do this is this allows for you to provide external configuration to those services. So for instance, a device service, you may have a set of static devices that you need for your POC, and those static devices do not exist in the upstream configuration file. So again, we allow for this external configuration to be provided. And if it's been provided, we also provide a configuration option that will say, hey, auto start this service. We use what are called snap content interfaces to be able to provide external configuration files, device profiles, vault tokens, any file that may need to be shared between the main EdgeX Foundry snap and an individual device or application service snap uses a content interface. A content interface is a special snapd interface. You can think of it almost like a container volume between snaps. It's a secure way to share files between snaps, not from the host system to a container. Next slide, please. Next topic, this gets a little bit deep, but I'm going to talk about what are called configuration environment overrides. So EdgeX configuration is essentially provided, we use a format called TOML for the configuration of most of the services within EdgeX. And you can go and you can modify the configuration files. In fact, the content interface that I just talked about is an example where you actually provide a whole new configuration file. But there are some times where you may just need to change one thing in that configuration file. And so, providing a whole new configuration file is kind of overkill. So EdgeX provides a way to override individual configuration options via environment variables. And these are called per service environment variable overrides. If you look at the Docker Compose files for EdgeX, these are used all over the place to customize the deployment of EdgeX using Docker Compose. So what we've done, oh, Dave, lost slides there. Thank you. What we've done over the last few months, in addition to working on content interfaces, has been to build a mechanism to allow us to specify these configuration environment overrides using what's called the snap configure hook. So snaps have a number of hooks. I'm not going to talk about any of the other hooks today, but the configure hook is a way to provide configuration to a snap. And what we do is we've created options that we prefix with .env, which create these environment variable overrides. So effectively what they do is if you set one using the snap configuration hook, under the covers, we create a .env file that a service wrapper then reads before it starts the EdgeX service. And that's how the environment variable gets passed to the specific service. The snap config can be supplied in a number of different ways. You can use the snap command line, as I showed on a previous slide. You can also use Snapd's REST API, and that's also protected by its own interface called Snapd control. Or finally, you can use what's called a gadget snap. And a gadget snap is the snap that's part of every Ubuntu Core image. The gadget snap provides the bootloader, but it can also provide default configuration for other snaps that are built into that image. So again, I've got a little note at the bottom here. If you use the first two methods, right, either using the command line or the REST API, you need to restart the service to pick up the new environment variable override. Whereas if you use the gadget snap, that configuration is provided to the service before the service even starts. So that's a very powerful facet of Ubuntu Core images. Next slide, please. So here's an example of just setting Core Data's port to the name of one of my favorite albums. Bonus points if anybody knows who that is. But here we've basically, I show the prefix env dot. We include the service name because, again, the EdgeX Foundry snap has all of the service in it. So you have to identify which service we're providing this override for. And then service.port, those are values that come, you can see those in the configuration.toml. Those are the values that we're overriding. So under the covers, this creates a service.env file for core data and sets the environment variable service underbar port equals 2112. Next slide, please. One other really cool thing we did with snap configuration, one of the parts of the system that can be somewhat confusing or daunting for people is what we call the API gateway. And the API gateway is really EdgeX's name for Kong configured in a particular way to protect all of the EdgeX services from access by unauthorized clients. So if you want to talk to core data from an external device, you need to do that through the API gateway. You need to authenticate to the API gateway and provide it some sort of authentication token, which allows you to make that call to core data's REST API. Now, the one issue with the API gateway is it needs to be configured before it can be used. So if you just bring up EdgeX by default, the API gateway is not configured. Well, what do you have to do to use it? At minimum, you need to add a user. You need to add that entity that you're authenticating against, right? If you're using a key to generate a token, and that token is bound to a specific user that's been added to Kong. So we added a snap config option that makes it very easy to configure the gateway user and include the public certificate key with that user. So you then can generate your tokens elsewhere. And we also added some snap config options to allow you to easily configure TLS. So by default, Kong generates its own self-signed certificates. That's great for POCs, but you might have a POC that you actually want to deploy in a real customer site. In that case, you might be required to actually use some real certificates. So we've made it fairly easy to do that as well. And, I mean, the bottom line is these options allow you to build an Ubuntu Core EdgeX image with a pre-configured, ready-to-use API gateway. Now, the last point I'll make is this release, the security team added a new command called security config, and we actually leverage that command under the covers. And it's still available for advanced use cases. So we're not precluding you do anything advanced. We're just making it very easy for you to set up an image out of the box that just works. Next slide, please. And this is just an example of this is showing from a command line. And because this is from the command line, if you remember back 2 slides back, I said, you do it from the command line, you have to restart the services. Ideally, we would do this from a gadget snap when building an image. But in this case, we're creating a user called user01 with just the string user ID as the ID. And I'm not going to embarrass myself and try and identify the actual crypto algorithm that's there. But the second command is actually showing the public key being supplied for that specific user. Next slide, please. So this is, I did want to dive deep here. We will follow this presentation up with a webinar on actually how to build your own application and device service snaps, which will, and images, and we'll go into far more detail. But from a high level, to construct an Ubuntu Core EdgeX image, you essentially create what's called a model assertion. And a model assertion is just a JSON document that is signed. And in that JSON document, one of the attributes is a set of snaps that you want to build into the image. Beyond that, you need to provide your configuration to those snaps, again, using the rich configure hooks or the content interfaces that I've talked about earlier. That could be done either via, you can use another configuration snap to provide that information, or again, you can use the gadget snap. So we have a tool called Ubuntu Image, which model assertion plus Ubuntu Image, potentially your own gadget snap, your own application and or devices snaps, and you can build an Ubuntu Core EdgeX image custom tailored for whatever type of POC or use case you can dream up. For more details, there's a link here on how to actually go about building Ubuntu Core images. And next slide, and I think the next one's my last. And the last one is just, these are some pointers to the snaps I talked about earlier that are in beta that are providing these features. And one last thing I'll say is we're working on landing all of this work that we had done on top of Hanoi into Ireland. This is just going to be a standard part of the EdgeX snaps moving forward. We'll be, again, you should see much of this documentation migrate into just the standard snap README files for all of these repositories. So that's it. Thank you so much for your time.
Okay, we have one question in the Q&A. Maybe we are going to answer that at the end of the presentation. Let's dive a little bit into our roadmap. What we can see in this slide is, on the one hand, on the upper side, the timeline of EdgeX Foundry releases, and on the other hand, on the lower side, Canonical's support offering. With Ireland being a new major version, we consider it a transition one towards Jakarta, which we will take as our next stable release, and the version that we want to consider as LTS one. As far as I know, this is aligned with the intentions of EdgeX. So our recently released version based on Hanoi is the one that we consider stable, and our suggested version until Jakarta is released by Q4. And we keep our version based on Hanoi in our own mirror, and it is the one way we suggest for POCs and demos for early adopters. And on the other hand, we are also going to be aligned with Ireland and the upstreaming directly our changes and bug fixes. And we will provide, of course, support for developers who want to go for to continue developing with Ireland and to go for production with Jakarta. From a product perspective, EdgeX is integrated in our devices and IoT offering with no special service associated with it. Okay? The services we have can be classified in two blocks or into groups. On the one hand, we have the services that allow our customers to accelerate their time to market. With our ODM program based on specific hardware enablement and certification, we help our customers to port Ubuntu to its custom hardware, and we create a catalog of certified devices with a specific operating system or software. And the Smart Start is a package that takes advantage of that. Okay, customers that can use pre-certified board or device can benefit from a pack of services that will reduce the time to market. They can have a dedicated brand store for up to 1,000 devices and several days of consulting, among other benefits. On the other hand, we have services that cover the long-term engagement for up to 10 years that I described during the presentation. They are mainly security and application OTA updates, keeping the devices up to date and secure for their whole life cycle on the field, and support. And with this, we have finished the presentation. I don't know how we are with time and if it is worth showing the demo, which is going to take around 3-4 minutes. Jim, Brett, what do you think?
Yeah, we actually have till the top of the hour, so you have another 20 minutes.
Okay, what we are going to see is a very rough kind of emulation of a retail store where we have a camera and an RFID device connected to an Intel NAC. The camera is periodically taking snapshots and sending images to the cloud, and the RFID acts as a detector of inventory elements. So we detect arrivals and departures of articles which have an RFID tag. For that purpose, we have two device services, one for the camera and other for the RFID, and two application services, one for connecting to the cloud, where we have an InfluxDB instance with the Grafana board, and the other one keeping the inventory of the RFID services. And we have integrated an RFID tag in the toy octopus, and we will see now in the video. Okay, in the upper left side, we see the number of events of detected articles, and on the upper right side, the number of events of the not detected articles. Okay, so SIGI is just bringing in the octopus, leaving it on top of the table where there is an RFID reader, and the camera is taking the snapshots every 15 seconds. And we are seeing a graph of the events, okay, the arrivals and the departure of the different articles, and the snapshots of the camera. Okay, so this is a very, very, very simple demonstration of how we could deploy an application based on snaps on Ubuntu Core. Okay, and as a wrap, what we have seen today is EdgeX running on Ubuntu Core as snaps and the services that Canonical offers. And these are the main benefits of that combination. First one is that customers can focus on their application development, forgetting about the underlying operating system and security and so on, and thus accelerating the time to market. Customers also will benefit from an OpEx reduction because of maintenance and operations features, and of course, the security and reliability of the devices for their whole life cycle on the field. So that's it. Thank you very much for joining us today. I hope you have enjoyed the presentation, and now it's your turn to ask questions.
So David, why don't I take the first one? It looks like they're both from Rodney. So good morning, Rodney. Yep. So the first question is there documentation and where as to how to quickly launch an instance of EdgeX using snaps and configuring it to use a device profile one may have written? So the individual links that we've provided on that last slide that I presented, Rodney, have some documentation on how the content interfaces work and how you can supply configuration to those device services. But as I mentioned at the beginning of my talk, we plan to follow up with a webinar, right, and more material on how to do this, white paper webinar. This is how you easily build an EdgeX application or device service snap. One other thing I note, which I didn't mention during the talk, was that the rich configuration hooks, we actually wrote those in Go. You can basically write snap hooks in whatever language you want, and most commonly Bash is the most common language that's used for hooks. But we actually rewrote the hooks in Go, and we created an additional Go module, which we call EdgeX snap hooks, which anybody can leverage to basically easily build these configuration overrides. So, look for something to follow on that. Next question, I'll let you answer, David, about support.
Yes. Okay, the short answer is yes. Okay, the long-term support include EdgeX. Long-term support term is not a term specifically coined for IoT or Ubuntu Core. It's something that in Canonical we use for the period of time that we are supporting our Ubuntu releases. And of course, Ubuntu Core is benefits from that, and we support up to 10 years our operating system, just providing security updates and so on. And additionally, as I mentioned during the presentation, EdgeX is included in the let me say this way, in the catalog of applications of IoT. Okay, so we have a selected bunch of applications that we support, and EdgeX is one of them. And what we support is the whole operating system plus EdgeX for our customers. So that's. I hope that this answers your questions.
But I think what he was asking specifically was about the 10-year support for EdgeX, and Rodney, I think that is going to depend somewhat on what we end up as a project deciding for EdgeX itself in the LTS release in Jakarta. So we're essentially doing best effort support on the Hanoi snaps until Jakarta releases. When Jakarta releases, that'll be an LTS release, and we would most likely will just align with the support term of that LTS, but we have the option of extending that as well. But the other interesting thing is if we as a project provide tools to allow migration from one version of X to another EdgeX, that also would be super helpful to customers that want to run EdgeX for a longer period of time and have it supported. You good with that, Rodney?
Folks, too, if you'd like to ask a question live versus chat, just raise your hand, and we can get you connected here. And while we're waiting for the next question, Tony, David, great presentation. Thank you. I've got a question. So, Tony, you mentioned with Snapd in any kind of Ubuntu environment, I can run snaps and also be containerized, or you had a term for it, but essentially take advantage of the security features of Snap. So why would I want to go to Ubuntu Core if I could do that, say, on Ubuntu desktop or Ubuntu server with the same mechanism?
Yeah, that's a great question, Jim. Thanks for asking it. So your system is only as secure, right, as the host operating system, right? If you're running Docker and you're running something contained, what are you running Docker on, and how secure is that host operating system? Now, what I'm not saying here is that, you know, Ubuntu server is insecure. Ubuntu server can be made very secure. Depends on how you deploy it, your use cases. With Core, what we've done is we've locked it down by default, right? On server, right, our classic images are basically built of traditional Debian packages. And traditional Debian packages are not confined by default. So while you can install the EdgeX snaps and they're secured by default, what about all the other things that are installed on that server? You know, so with Core, everything's a snap, everything's locked down. So it really just depends on the use case. We really envision Core as something that's deployed at the edge. It's not, right, something in the data center where the security needs are different. Does that make sense?
It does, Tony. Yeah, thanks. You got a question from Joe on the chat?
Yeah, the question is, does Ubuntu Core support any real-time use cases? Okay, this is real-time is a very controversial term, by the way. Okay, but what we typically understand by real-time, which would be real-time patches for the kernel and so on. This is something that right now is not supported by Ubuntu Core because it is not supported by any Ubuntu kernel, but it is in the roadmap. Okay, so that's something that in the next cycles we will have available. So currently it doesn't, but in a near future it will. If you understand from for real time, the application of real time patches to the kernel.
Don't see any other questions yet, guys, but I've got another one for you, Tony. So if you've done a great job providing the snap that provides all the ingredients to get somebody up and running quickly, including the device virtual. So once I've learned EdgeX and I've got it up and running, and now I want to, you know, kind of custom tailor it. In particular, I want to do things like probably remove the device virtual for simulation. Would it be your suggestion at that point that it's time to go to the advanced topics that you kind of covered and build your own snap, or what would you advise people at that point?
Yeah, well, that's an interesting question. So at the moment, it's not possible to remove device virtual from the snap because we ship it as part of the snap. Now, you know, size-wise, we're talking 8 to 10 megabytes. So it doesn't contribute to, you know, making the snap much bigger. As I mentioned, a lot of services in the snap are disabled by default. So the SMA, support scheduler, support notifications, they're all turned off by default. If you want to use them, you can enable them. If you want to stop them, you can disable them. So that you have that choice with device virtual. Did I answer your question?
You did. Thanks, Tony.
You're welcome.
Giving folks here another second or two to provide their questions while we're waiting. Again, David and Tony, thanks so much for the presentation. Of course, we really appreciate all that Canonical's done for the EdgeX project, and most importantly, and including taking over the snap and really kind of managing that ever since the fall. It's been a great help to the project. Of course, Tony's and Siggy and all the other folks at Canonical helping on the project has been a great boon as well. But a great partner, and we really appreciate it. Checking to see if we've got any last questions, and I don't see any coming online. So I think with that, we'll close out. Again, thanks everybody. And the slides are available both on our EdgeX Wiki, as well as available through our website, our main website, edgexfoundry.org. I want to thank the guys again and look forward to hearing from everybody soon in the next Adopter series.
Thanks, everybody.
Thank you very much. Bye.